Thank you very much for coming for today's talk. We will give you an update about Capri. If you don't know what that is, that's fine. So Dan and I are both RabbitMQ core team members at VmWare. And let's start with what is Capri. You might have attended earlier RabbitMQ Summits, and I've heard the name, but yeah, maybe it's your first RabbitMQ Summit and you are not sure what the hell that is. So Capri is our next generation schema or metadata store that will replace Ninja in RabbitMQ. It is Raft based, so there are similarities to etcd and console. And one of our primary goals with it is predictable failure recovery semantics and well understood consistency and availability guarantees. So why are we doing it? Well, RabbitMQ is what, 15, 16 years old, and Nisha helped us get where we are today, but it has pretty serious shortcomings as far as distributed data stores go. So the recovery procedure is not particularly well defined, and in fact, it involves one side of a partition resetting itself one way or another. And that tends to be a little chaotic and inefficient and just surprising to developers and technical operations folks. Also, Ninja baggage is substantial. It's over 20 years old. And we personally on the RabbitMQ team don't expect it to ever significantly change. So another reason why we're developing Capri is that our attitude towards transient entities, transient things, has changed significantly. So temporary and short-lived entities like queues, maybe even streams, yeah, they have their purpose, right? Their place in the developer toolbox. But for the most part, what we see in the wild is that most folks end up with transient entities, not because they want them to be tied to a connection lifecycle, not because they maybe intentionally used TDL, but simply because there was a default somewhere that, the value of transient for queue durability or something like that. There was a library, a framework, one of their coworkers copied a tutorial many years ago, that kind of scenario. So many people end up with transient entities without necessarily meaning to. So finally, we think that not only the time has come for RabbitMQ to be like 98% durable storage, and 2% of features will be transient, but also we think that with Capri and our experience with Raft and quorum queues and streams and super streams, and just distributed infrastructure, we can probably do better than Ninja on most accounts on predictability, maybe even on throughput, on time to recovery and similar metrics, and on lock intention, for example. So this is great and all, but Capri has been an R&D project for us for a couple of years. So let's see what happened in the last year. Diana, take it away.
Yeah, thank you, Michael. So now we have roughly 2 or 3 team members working almost full-time on Capri. Last time we talked about Capri, we only had things like users, vhost, quite simple entities stored on Capri. Right now we have everything that is on Nisia, like a key value store, is also on Capri store. We have queues, we have bindings, we have exchange, we have migrated everything. All the plugins that ship with Rabbit, they have also migrated to Capri. The only thing that we don't handle yet with Capri is the cluster membership, that we still rely on Nisia for that. But that's in the process to change. One of the important changes that Michael mentioned is that we dropped the support from transient entities. What means we don't have transient queues, transient exchanges, or transient and semi-durable bindings, which are quite weird things, and make things very complicated on recovery or when a node goes down, because we start doing a lot of weird things, changing state, removing things like that. But exclusive queues remain there because that's a completely different use case. We've been benchmarking Capri and Nisia. We do better than easy in some cases. We match in others, and some other cases we are still doing worse. But up to now, every case that we try to match, we manage to get the same performance. One thing that if you try Capri right now, you will see the most important thing probably is that if you publish and consume messages, it's way slower. But that's because we still miss the cache implementation. When you use Nisia to route a message, we don't use any of the consistency of any guarantee from Nisia. We use the cache that is an ETS table. So that lookup is really fast. So we have to try to match that with Capri. A few months ago, we did a spike introducing a cache on Capri using ETS tables too, and we can get the same performance. Right now, one of my colleagues, Michael Davis, is working on a proper implementation of that cache. And when that is available, we'll have the same performance publishing and consuming messages. Next slide, Michael. Thanks. So what happens adopting Capri? Well, basically you have to change all the code base because we are using Nisia in many places for queues, for exchanges, for everything. Every entity, almost every operation goes through Nisia or Capri at some point. The good thing is that we are improving other things at the same time. There is code that is suboptimal in some cases. Sometimes we do things that maybe they are not needed or we can optimize in a different way. That's how also found out that like, yes, we really should remove transient entities. They don't make sense. And all these kind of things that now we are rethinking about. You have to think that RabbitMQ is quite an old project, so we had a lot of legacy code around. And we can work and make it better now. So even this week, I fixed a few things like this, like, okay, we can do this better. And we were doing them wrong in Nisia already. In some cases, we manage an impressive speed up, like a 70% gain with some topic exchange operations that we will see now in the benchmarking. Next slide, Michael. Okay, so we are showing some of the nice cases that we have right now. This is when you import definitions. So for example, now importing 1,000 vhosts on the system, the light blue is Nisia and the dark blue is Capri. You can see that it's much faster. What does vhost do? Writing a vhost to Nisia or Capri is not expensive, but when we import a vhost, we recover all the semi-durable transient kind of things. So all these operations to try to recover any data that could have been on the vhost are very expensive. But we optimize things on Capri and we also skip all this transient stuff. So recovery is really quick. So if instead of that, we try to import 100K topic bindings, we are better, not much better. But if you do the 1,000 vhosts and then the topic bindings, you see the big difference. We are saving a lot of time on all these kind of operations. So now starting a node or importing data from another node is going to be much quicker. Million topic bindings, which were the most expensive of all. Next slide, Michael. One important thing we have to look at is also scalability, how better we do as the more nodes we add. Once again, we have 1,000 queues with 100 topic bindings each. So if you see Nisia, as soon as you add more nodes to the cluster, is way, way slower because mainly of all this recovery process. But with the new changes on Capri, because of how we implement the topic bindings and how we skip all those recoveries that are not needed again, we can boot a node or import data on a much faster way. And now Michael is going to explain you a bit more of all the details of how we made all this more efficient.
Yeah, thank you, Diana. So what's our plan for being more efficient than Nisia, or what have we seen so far? Where does this difference, where does it come from? So there are several areas, like the structure of your schema is slightly different, where in Nisia is tabular, right? And Capri is tree-like. So you can sometimes express things against, with Capri, you can express your data schema sort of more elegant, right? With fewer things, simpler structure. So fewer entries and operations compared to Nisia. Now we have removed transient entities in the Capri branch, or well, I'm getting a little ahead of ourselves, but when you enable the Capri feature flag, then all your queues, all your exchanges, so on, will always be durable, which means when you recover, you don't have to recover that transient data and then throw it away, which is roughly the process that current RabbitMQ nodes use with Nisha. We had to review every single metadata store use case, even if it was introduced in like 2008. We have some Capri improvements coming up. They have to do with caching one way or another. And finally, today we require Roll-Line 24, and by the time 3.11 ships later this month, Capri and Rabbit, well, Capri will not be included in 3.11, but we have made the decision to require Roll-Line 25 for RabbitMQ 3.11 and later on, and we will talk a little bit about why in a bit. So yeah, fewer entries in operations. This is one of the areas where you get a lot of gain, right? Because if you don't have to load multiple, say, keys, you can load all of them in one operation. Chances are that it's going to be more efficient just algorithmically. For topic bindings is the biggest beneficiary of that right now. So if any of you use topic bindings or MQTT and Stomp plugins, which are topic oriented, even in their future versions, those features will benefit from Capri and this simpler structure. We had to review every single metadata store operation and move it from Nisha to Capri behind the feature flag. So that forces us to do things differently from Nisha. I'm obviously not going to cover every single case, but because there are thousands of them. But yeah, sometimes when you profile things, you notice that doing things exactly the same way with Nisha doesn't make much sense. Like at some point, we have seen data migration being 60 times slower compared to Nisha. Then with very little work, it turned out to be 3 times slower. And now, in some cases, it's 10% faster. And in other cases where we have seen, it's actually more than 1 order of magnitude faster. So rethinking and revisiting every single thing that we do can lead to pretty remarkable improvements. Another thing that we had to reconsider is because Capri is built on our existing Raft implementation, which is tuned towards the needs of quorum queues and streams. It did log snapshotting, that is Raft log snapshotting, in a specific way that doesn't make much sense for Capri. So for example, we initially observed massive memory consumption during definition import, for example. But now our Raft library has features that allows you to basically delay snapshotting in some cases. And that means that Capri can avoid the snapshotting that serves no purpose, more or less. You can snapshot once at the end of definition import, for example, and that memory consumption instantly drops. So that wasn't a Capri improvement, but the Capri migration forced us to revisit that area. Capri has multiple consistency options. So technically, Nisha has 2. So it has consistent reads, which is a cluster-wide transaction, and dirty reads, which means just read from the local table. So you can consider this reading from a local cache. So Capri has the same consistent query, which is basically read from the leader and wait for a majority, any majority of the nodes to respond. That it's not a cluster-wide transaction in this sense. You wait for n+1 divided by 2 number of nodes. There is an option to read from the cache, and we will further improve it, so the low latency mode. And then there is a compromise where it works the way low latency works most of the time, but every 100th or whatever query, it uses a consistent query to make sure that this node is still in the Raft majority, and certain failures do not go unnoticed because you keep reading from the local cache all the time. So that gives us a lot of flexibility. Some operations can rely on certain consistency guarantees. Others can use local cache, and this is much, much closer to how most popular distributed data stores work today, compared to Nisha, where yes, you have 2 modes, but it's kind of it's a black box. You don't really know what it does because the protocol is homegrown and you have to reverse engineer it. Well, read the source, right? So to understand. So Capri projections is it's a feature that hasn't been merged. It's a work in progress, but it demonstrates what can be done when you are in charge of developing your own internal data store, as opposed to relying on someone else for doing this. So what are Capri projections? They're database views, for those of you who may be more familiar with this term. So you give Capri a pattern and it caches a subset of keys for you in an ETS table locker. Then as Capri keys are mutated or updated, so are the projections. For a subset of keys, we can just query those ETS tables. This is probably the most efficient option on the VmWare. Like any cache, it trades compute resources for RAM. So again, we won't use it for everything, obviously. And that's just probably your main tool in reducing query latency where you most need it, like when querying, say, bindings, right? Because it's on the hot message path. So Erlang 24 and then 25. With Erlang 25, you get the benefits of the JIT, regardless of whether you run on x86-64 or 64-bit ARM. In Erlang 24, only the x86-64 architecture is covered. Some anecdotal evidence, when I use an M1 Mac versus an Intel Mac, to develop the same feature in RabbitMQ, my test suite runs usually finish at least twice as quickly on Erlang 25, because that's an ARM architecture. And yeah, you get the benefits of the JIT versus not having them on Erlang 24 on the very same machine. But interestingly, just some anecdotal evidence. If you compile RabbitMQ on Erlang 23 and run it on 24, and then compile it on 24 and run exactly the same workload on 24, you get single-digit throughput gain by doing literally nothing else, right? So it's free throughput improvements. So what happens when you compile on 25 and run on 25? We will actually know soon enough, because right now there is a couple of plugins that need adapting for Erlang 25. And as soon as those are done, well, there is one plugin actually. It's a small plugin. I'm not going to name it. It doesn't matter. So once that is done, we will be able to require Erlang 25, use it in our pipelines exclusively, things like that. So yeah, the compiler and the runtime, they keep improving, but sometimes to benefit from that, you have to actually you have to actually compile on the latest version. Lock-in is the next area where Nisha does a fair amount of lock-in for you, and you usually don't know when that happens, which of course is nice in some ways. But with Capri, we're forced to effectively revisit where do we use locks, why, and do we actually need it or not. So curiously, we have observed that lock-in in Capri makes concurrent workloads, RabbitMQ workloads, more efficient. So how the hell can this be the case? So Capri uses bytecode generation under the hood for transactions. It supports transactions, and it generates some code for every function where you use a Capri transaction. So without lock-in, you may end up with concurrent code generation, which is very, very expensive. So we'll use lock-in there. It doesn't make sense. So you get extra lock-in very early on boot, and once your code executes every transaction, every kind of the transaction that we have in the code base, then that lock-in becomes, well, close to irrelevant, because the time it takes, the time between the acquisition of the lock and its release, it's negligible. Another area where Capri is different from Nisha is its approach to storage. It is entirely borrowed from or implemented by our Raft implementation, It is an append-only store. It stores a segment of files of block state machine transitions. So if you have modern SSD or NVMe drives where append operations are drastically more efficient compared to spinning disks, you get a nice improvement with this kind of stores. And it deployments compaction in a way that is heavily geared towards queue and stream semantics, meaning you have a constant data flow, things constantly come in and go out, right, and get acknowledgements back. With Capri, it's not necessarily the case. Your topology can be surprisingly static, like you import your definitions, and then your topology doesn't change at all for hours, days, maybe even months. So snapshotting in the same way doesn't make sense for Capri. I've already mentioned that snapshotting frequently during definition import doesn't make sense. You also need periodic snapshotting, something that quorum queues and streams don't necessarily need. So this is another area of improvement for a Raft implementation that Capri has made necessary. So yeah, generally you get all the pros and cons of Ra and all the optimizations, and Ra has been optimized quite a bit in the last couple of years. They benefit Capri, well, most of them. There are certain areas where we have improved Ra, but it doesn't really change much for Capri. Capri doesn't store large payloads, probably never will, because your topologies, they are not tens of gigabytes or hundreds of gigabytes in size. Also, Capri is a single Raft cluster. So consider this like a one queue or one stream or one super stream manager. And it means that it will use fewer cores on average, just because it's a single subsystem instead of every queue and every stream being its own Raft cluster in the Erlang cluster. So some optimizations when it comes to the number of Raft clusters we can concurrently sustain, they don't make sense. Well, maybe they do make sense, but they don't change anything because there is only one instance of Capri in a RabbitMQ cluster. Finally, because to optimize things, you have to usually profile things first, unless you're very good at guessing. And because Capri performs code generation, it can confuse profilers, or at least make their visualized data significantly less useful. But so currently we do most profiling at the RabbitMQ level, or maybe Ra level. Those projects do not have this problem, but at some point we will have to, I guess, see what profilers we can or cannot use with what kind of settings to, get useful data for Capri itself, especially for the transactional part. The non-transactional part is not affected. Cool. So those are some of the internal changes and differences. And now over to Diana to tell you about some user-facing changes that will come to RabbitMQ with and because of Capri.
So basically, all the changes we are doing with Capri, we are trying to maintain the same API, the same behavior on Rabbit. So the final user, the application developer, won't not notice the difference between Nisia and Capri. But one of the things we want to solve with Capri is the issue that we have with Nisia when there are partitions, when there are network glitches. What happens? Well, with Nisia, it's a bit of a chaos. If a node is a minority and we have the option of use pause minority, the node will disconnect, we'll start doing a lot of weird things. So all this is solved using Capri because we have Raft, and Raft is very predictable. We know what is going to happen on every case. But that also means we have to accept one thing, that now if a cluster is on minority, it won't work. If the majority of your cluster has gone down, the node that is up, even if it is up, it won't be able to answer any request. You won't be able to access Capri, so you can't log in. You can't send messages or receive messages. You can't connect, open new connections. That before with Nisia, some of them were possible, depending what strategy you use. But we know that quorum queues and streams already work this way. If they are in minority, they won't work. So you have to ensure that most of your cluster is still working. We could have some compromise. We've been thinking about it, being able to provide some metrics, a small subset of the admin operations, things that we could do. And maybe still be able to route the messages from existing connections, because quorum queues and streams won't work. But if you have a single classic queue, not mirror classic queue, that will still continue serving messages. So that's a possibility that we are considering. But in general, we know that a minority cluster won't work, but that's what gives us data safety. So that is how it's going to work. There is also another difference on the way we start up the cluster right now, because with Capri, we need to start nodes in parallel, because you need a quorum of nodes to be able to work and to start things. The good news is, as soon as we get rid of Nisia, we can remove these partition handling strategies that caused so many grief before. If you're a cluster operator and you have to deal with network partitions and this kind of stuff, you know how hard that is to reason about and to solve. So all that is going to be a given with Capri. But yeah, this is the main thing that is going to change. The rest should be the same for everyone else. And now Michael is going to explain what we plan to do with Capri and how we are going to start releasing it.
Yeah, thank you, Diana. I also have one thing to add, is that because with Capri, RabbitMQ will be very heavily Raft based, I expect that your cluster size may grow somewhat larger, so that you have a very substantial kind of headroom for the failure of how many nodes you can tolerate. So maybe if you run 3 nodes today, you might find it optimal to run 5 nodes or something like that. We don't expect that anyone would need, well, most environments would not need more than 5 or 7, but if today the recommendation is start with 3, maybe the recommendation will change to start with 5. 3 will also work. In fact, a single node will work. But yeah, with Raft and Capri, as you know, for operations, it will be crucially important to have a majority of your nodes up. If you lose a majority, well, you'll basically lose your cluster, more or less. So maybe average cluster size will go up. We will see. That's just a guess, of course. But let's see, what's the adoption plan? So all these changes, when are they coming? And how can you experiment with a Capri-based RabbitMQ today? So there is one adoption plan for 3.x and another for 4.x. In 3.x, so in 3.12, maybe 3.13, whatever happens to be the release in the first half of next year. Capri leaves behind the feature flag. If you enable it, data is not moved, but copied from Nisha to Capri, and RabbitMQ starts using Capri for almost everything, in fact, now. And eventually, probably will be everything. You can still go back. I don't think it would be really advisable, but yeah, if you disable the feature flag, then your data is copied back, and RabbitMQ will still be able to use Nisha-based APIs. Obviously, if you form your cluster and then disable the feature flag, there will be surprising behavior, because cluster membership, there will be 2 different cluster membership systems. And when you switch from one to the other, nodes potentially won't necessarily know that they had these fears before, at least in some scenarios. I can see how that's going to work. And also doing a rolling upgrade with the difference in feature flags, again, like these are 2 different membership systems. It's just not going to work very well. But what it means is that if you don't want to run with Capri, if you consider it to be a little too novel, you don't have to. So how can you try it today? There is a separate branch that you can build and test today. We will talk about that a little bit in the next 2 slides. And as I mentioned, this should ship, I don't know, in the first half of next year. What 3.x version is going to be by then, I don't know. My guess is 3.13 or something like that. But you can begin testing it like in the next hour or so. So for 4.0, the adoption plan is that niche is no longer going to be an option. And the only viable upgrades to 4.0 will be their blue-green deployment. If you don't know what that term means, is you spin up a new cluster and you migrate your data and your apps to it using a pretty widely understood procedure that can be partially automated. Or you can upgrade to the latest 3.x branch, enable the Capri feature flag, and then it will be very much like a minor version upgrade from that moment. But you will have to be on the latest 3x minor. So how can you try it today? We have a branch where RabbitMQ is adopting Capri. It is extremely creatively named Capri-Qs. It's a lot more than queues now, but you know how it goes, the names. Our pipelines produce releases from that branch. You can consume them, for example, as a Docker image from, well, using this Docker hub.org and image tag. This will give you a Capri-based RabbitMQ 3x, which is usually rebased against main. So basically RabbitMQ 3.12, future RabbitMQ 3.12, every maybe few weeks. And it runs on Erlang 25. So we would appreciate any feedback on it. So if you offer RabbitMQ as a service, maybe you're a company whose name begins with an A or a B or a C. There are some companies I hear that offer RabbitMQ as a service. Maybe try integrating this Capri branch into your existing automation and tell us how it goes. We don't expect that everything will be super smooth, but we tested on Kubernetes, and your deployment tooling is probably different from our Kubernetes operator. So we are curious to find out how well it's going to work for you. So yeah, thank you very much. And if we still have some time, let's open up for questions.
Thank you. From the company that starts with A, would you recommend new plugins to be developed with Capri? And second question, or second part, are there any guides or tutorials about Capri API?
We don't have anything at the moment because, as you see, it's very new. We're still on an experimental branch, but it's quite simple. There are a few plugins that use Capri, and you can follow them as a sample, like Shovel, Federation, GMS Topic, and I think one other. Consistent has changed. But in general, when you use Nisia or Capri now, you store a small amount of data, so it shouldn't be a problem. Also, you can ask questions on the mailing list, on the Slack, and we will answer. So it will be really nice if people start using it.
Thank you.
Yeah, as for the adoption part, this is very much a work in progress. Even though we work mostly on optimizing things now, not just porting RabbitMQ to Capri, I suggest that you treat it, your team treats it as, again, it's the future of RabbitMQ, right? So it's in our collective interest to start testing it early. I don't expect that, well, you won't be able to deploy it live probably in the next 6 months, maybe even 12 months, because your company probably has some procedures that take a while. But you can start today to get the hang of it. If you have ever used etcd or console and you know what that API looks like, well, Capri's API is even smaller. Capri has some docs in the README. It also has some examples. It has a lot of tests. It's a relatively small project. Except for the code generation part, I think it's pretty easy to follow. So I would encourage you to dive in. It's just, please treat it as an R&D project right now, but this is our collective future. So I think it's in our collective interest to begin testing it soon enough.
Okay, thank you. Any other questions in the audience? Oh, yeah.
you were saying that when a node finds itself on its own, that it stops with Khepri, which seems reasonable. But if the other two nodes are shut down cleanly, then it has the possibility of knowing that it's not on its own because of a network partition. Would it then stop in that case?
Well, it won't stop as such,
Yeah.
but it won't reply to queries. I mean, we still need to know how to handle that nicely, but it won't be functional. We'll be up and we'll be there waiting for other nodes to come up. We don't stop as we did with Nisia. The node will be there waiting for its peers.
Okay, even if it knows the other, let's say it's a 3-node cluster, the other two were shut down cleanly.
Yes.
Okay. There was another question. And in that situation, can you then tell it, please continue on your own?
No, you can't, because you need a quorum, you need consistency. That's what we try to provide with Capri.
Okay, thank you.
Yeah, I can add that this requirement that if your node ends up in the minority, then it cannot accept any, well, almost any client operations. I think routing on existing connections might be acceptable. It comes directly from Raft. In Raft, if you lose a majority of your cluster, then you cannot commit new log entries, which means you cannot really do much. With Capri, like you wouldn't be able to modify your topology. You would be able to read from your local cache, maybe route messages using the data in that cache, but that's about it. So if we have considered something like this before for quorum queues, but if you do something like that, then it's not a Raft implementation and your guarantees kind of go out the window. So etcd, I believe, or console have pretty extensive failure recovery guides. I suggest that you read them. We basically do either, well, some of the things that they do, not because we try to copy them. I guess that's how Raft implementations just naturally evolve. And there is a force boot option. I think it's an etcd. Maybe for Capri specifically, would be able to provide it so that you can emergency recover your cluster. That's probably worth doing. But just telling a node that, hey, please continue. The best we can offer is you can downsize your cluster temporarily to one node. But then whatever was onto other nodes, like it kind of won't be there, right? That's the best option I have. We have seen in Stefan's talk earlier today that if you perform your upgrade in a rolling fashion, this Raft limitation, it's not applicable, right? You never lose your majority unless you have a 2-node cluster, which we explicitly do not recommend anyone to run in the docs. So there are some middle ground options, but if you want to be a faithful Raft implementation, there is very little you can offer in this scenario. etcd and console developers arrived at the same conclusion. At least that's as far as I can tell. So yeah, hopefully this provides a little bit more details on our thinking.
I was just curious because Galera with MariaDB uses Raft as far as I understood, but listening to you, I think what happens is when a node shuts down in a correct way, it removes itself from the cluster, so then the cluster shrinks. So that must be how they get around it.
Okay. Our clusters.
Yeah, and we can do that with RabbitMQ. There are two problems still. One is how do you know what to recover and kind of bring back? So your existing, it's as if you have a cluster state that's not accounted for. That's really not how Raft is meant to work, even though maybe it makes sense for some projects. I'm not questioning that. Another problem is that you can do that with quorum queues and streams because there are many Raft clusters, right? You can migrate membership, things like that. You can effectively shut down a subset of your queues. Maybe that would be a better option for some environments. But there is only one Capri. You cannot really shut down one Capri. That shuts down your entire cluster. So yeah, maybe we will come up with some improvements, some guidance, but I think the primary piece of guidance is if you want to upgrade nodes like 2 at a time, then have a 5-node cluster, something like that. You can temporarily grow it to 5 nodes. Not sure if it would make sense, but that's one of the strategies to work around.
Okay, thank you.
Any other question in the audience? Okay, so
May I ask a question? Hi everyone.
Yeah, sure, go ahead.
Oh, hi everyone. I wanted to say that I'm from Erlang Solutions, and my name is Slava. I'm just working for the particular feature that the feature is how to recover the data after we lose the majority of the members, when the RA cluster cannot form a majority. So this question related to the RA. So we have a case, you mentioned it just a few minutes ago, that we have to recover by some way, but we don't have a majority of the nodes. So we have no leader which can approve the commit entry. And we provided like the solution, the special graceful method, which can take configuration of nodes, take this configuration, and run the cluster in the recovery mode. So it can run the minority members with well-specified configuration, which is indicated in the code base. And we were able to recover quorum queues. We were able to recover all the data. But this solution doesn't give you an opportunity to recover to rejoin the majority again. So just like recovery solution. What do you think about these potential configuration-based approaches to recover the data? Because they are a little bit against of their idea with the consensus, but they need it by the real use cases. So yeah, thank you.
Yeah, thank you. So I assume that you're working on the pull request for our Raft implementation that Capri will benefit from, and so will RabbitMQ. Yeah, that sounds like the disaster recovery feature is available in etcd, which means, yeah, we would be open to considering them. I cannot guarantee that we will adopt them, but something we do realize that we have to have some emergency recovery kind of option for a minority of nodes. If you just basically copy what etcd does, or re-implement it in the same idea in a way that makes sense for an Erlang library, that's great. To what extent would RabbitMQ itself with Capri be able to use that? We will have to see, because what you can do in an arbitrary route-based system, you may or may not be applicable to RabbitMQ for various reasons. May or may not be very like human and operator friendly. But we would consider your Raft contribution for sure. And if it allows you to boot a cluster of, say, 2 nodes temporarily and then grow it back in case of say, data center failure or something like that, sounds like a great idea. The team is not dogmatic about Raft. It's just Raft works very well. Raft works the way it does and is so widely accepted in industry now, exactly because it gives you some guarantees and you know what the limitations are. Once you start deviating from those limitations, well, you start deviating from the guarantees as well, and you have to be careful. But we're looking forward to a contribution. Thank you.
Thank you. Thank you.
Okay, any other question in the audience? Okay, so thank you very much, Diana and Michael. Thank you. I think they deserve a round of applause.
Thank you, folks. Enjoy the rest of the conference.